All right, in this lesson, we're going to talk about the centroid theorem and learn about where the centroid comes from. The centroid comes from the medians of a triangle. Now, we learned about medians earlier in the year. We're going to review it now. A median of a triangle is a line segment connecting each vertex to the midpoint of the opposite side. So, each triangle will have three medians. You can go from any point to the opposite side's midpoint. So basically what it says here is in triangle ABC, this picture here, D, E, and F are drawn, and those are the midpoints. It's given. So again, D is the midpoint of AB, E is the midpoint of BC, and F is the midpoint of AC. What we're going to do here is we are going to draw all three medians. If you have a straight edge, it would be really helpful. I don't have one on here, but I'm going to try to freehand it the best I can. So again, draw all three medians. You're going to connect, to draw a median, you connect any vertex to the midpoint. So basically connect the midpoint to the opposite vertex. So we're going to go B to F. I know it's swervy there. I'm trying to do the best I can. There we go. And then you're going to connect D to C. And then you're going to connect A to E. When you do that, so I drew three medians. Notice that the three medians intersect at a single point. That is called, that point right there is called the centroid. Okay, that is called the centroid. And it must always be inside the triangle. If you're connecting three medians, it's always going to connect inside the triangle at that single point. Because the medians of a triangle are concurrent. We haven't used that word in a long time, concurrent. But concurrent means that they intersect at a single point. This is just a refresher for you. It says it right here. All medians of a triangle are concurrent. That is, the three medians of a triangle meet at a single point. This point of concurrency is called the centroid, or the center of gravity of a triangle. So that is the center of gravity. You could balance a triangle on that point. You could find that point right there. You could put a triangle on your finger and you could balance it. All right, that is the center of gravity. So here's the centroid theorem. The length, well, once we have the centroid, okay, I want you to notice before I talk about the theorem, I want you to notice that the centroid divides the median into two pieces. That's important. I'm going to do a green piece. See, there's one piece. And then I'll do purple. A purple piece. See that? Green piece and a purple piece. Okay, I'm going to do that for each median. Here's the purple piece. Purple piece. Okay, and then green. And then green. Notice how all the green ones are longer and the purple ones are shorter. It turns out that there is a relationship for each median. Okay, so for each median, and what I'm gonna do is I'm going to now erase all but one. All but one, so we're not confused. Okay. The green piece is 2 times the purple piece. So if the purple piece is 4, if the purple piece is 4, then the green piece would be 8. Okay? If the purple piece was 6.5 long, then the green would be 13. Okay? So that longer piece of the median is double, 2 times as long as the shorter piece. And that's for each of those three medians. And that's what the centroid theorem tells us. The length from the vertex to the centroid is twice the length from the centroid to the midpoint. Okay? So we're going to use that theorem. We're going to do these examples here. We're going to be done with our video for tonight. We're going to bring this information to class, and we're going to work on it a little bit more tomorrow. Nice, easy lesson to end our triangle module on, our first triangle module. All right. So in triangle ABC, the medians are concurrent at F. So that means that this is the centroid right there, the center of gravity. DF is 4, so we're going to label that as 4. BF is 16. BF is 16. And AG is 30. AG is tough to label, so I'm just going to go like this. I'm gonna do a little. That's not very good. Okay, I'm just gonna go like this. I'm gonna go. Okay, I'm gonna say AG like that. I'm gonna put 30. Okay, because it's tough. They didn't give you the whole. They didn't give you AF and they didn't give you FG. They just gave you the whole thing. That whole thing is 30. All right. So now, based on that information, you should be able to find anything. But we're going to go in order of what it tells us. FC. What's FC? Well, here's FC. And that's the longer piece of median DC. FC is the longer piece of median DC. So that's going to be 2 times longer than the shorter piece. The shorter piece is 4, so this must be 8. All right, so that's going to be 8. DC. DC is the whole thing, the whole median. 4 plus 8 is 12. See how the shorter piece is 4 and the longer piece is 8? That means the whole DC must be 12. AF. Now, AF is the longer piece of this median right here, of the AG. AF is the longer median, the longer piece of AG. So let's see how that works. Well, what we're going to do is we're going to call AF 2x, and we're going to call FG x, because I know AF is 2 times as long as FG. So if I say 2x plus x equals 30, I know the total is 30, so I can add 2 times and 1 time, right? And that's 3x equals 30, and x equals 10. So I know that my shorter piece here is 10, and my longer piece is 20. Okay, if the shorter one's 10, the longer one is 20, and that's what we wanted. We wanted AF, and that's 20. Okay? BE. Now, BE is the entire median here. We knew BF, right? BF was 16. I got to put that back in there. BF is 16. If BF is 16, EF must be 8 because it's half. The shorter one's half the bigger one. Then the whole BE, the entire BE is 16 and 8. 16 and 8 is 24. FG we found to be 10. We did it right there. That's 10. And EF we said was 8. All right, so we got all the pieces there. 4 and 8 makes 12. 8 and 16 makes 24. 20 and 10 makes 30. So we'll see how it's a bigger one and a smaller one, and the bigger one is double the smaller one at all times. It's like a little puzzle. You could figure it out. As long as you know the centroid theorem, you're going to be good to go. I'll see you in class to practice these skills.